Okay, so in this video we're going to talk a little bit about formal charge, and I have three definitions here for formal charge. So formal charge can be assigned. You can find the formal charge of a particular atom in a molecule doing the valence electrons minus the assigned electrons. Or another definition is that you can calculate it using the valence electrons minus the electron count, and this is how the books call formal charge as the valence electrons, your book that you use in lecture, minus the electron count. Or we have definitions online that says it is a valence electrons minus bond connected plus lone pairs. I'd really like the third one. I think it's the simplest one, the simplest way to see. So here I have two particular molecules, carbon dioxide and O3, and I wanted to assign formal charge for each one of the atoms in that molecule, in a CO2, and in that molecule. So my first step, what I need to do is draw the Lewis structure for this molecule and draw the Lewis structure for this molecule. Let's work with CO2 first, and then let's work with O3. So I know that carbon has 4 valence electrons. I know that oxygen has 6 valence electrons. Because I have 2 oxygens, this would be 12 valence electrons. Give me a total of 16 valence electrons. So now I draw the Lewis structure. I have carbon in the center, oxygen and oxygen. So 2, 4, 6, 8, 10, 12, 14, 16. So this oxygen has 8 electrons. This oxygen has 8 electrons, but this carbon has only 4 electrons. So we can use one of these lone pairs in this side and make a double bond. Another lone pair on this side and make the double bond. So the Lewis structure for this particular molecule, C-double-O, in both sides. Now that I have the Lewis structure here, I start checking. I will write it down on here. Now that I have this Lewis structure, you check if I have charge associated with this particular atoms. So what I do here for oxygen, first I know the valence electrons. For oxygen is 6 minus, now I say bond connected, so I have 1, 2, I forgot to put the dots in here. Okay, so I have 2 connections plus lone pairs, I have 2. So 4 electrons. So 6 minus 6 gives me a 0. Carbon has 1, 2, 3, 4 connections. Well, 4 valence electrons minus 4 connections plus 0 lone pairs gives me a 0. And this oxygen here has 6 valence electrons minus 2 connections plus 4 lone pairs, so 4 electrons, gives me a 0. So I have a 0 for this particular atom, 0 for this particular atom, and 0 for that particular atom. Now let's work with the O3. O3 valence electrons, I know that oxygen, each one has 6 valence electrons. Because I have 3 oxygens, I'll say times 3 gives me 18 valence electrons. So now I start thinking about the Lewis structure. So 2, 4, 6, 8, 10, 12, 14, 16, 18. If I look at this particular atom here, I have 8 electrons, valence electrons, so this is happy. This is not, because it has only 6 valence electrons, and also this obeys the octet rule. So what I could do, I could use one of these lone pairs, dump it in there, making this, just a review from what we already learned in chapter 1. This guy has a resonance structure that will be this other molecule here. And remember, Lewis structure talk about localized double bonds, and really what we saw in the lab is that this bond is not localized. It's flowing between this and this connection. Therefore, we say that the structure is not this, it's not this, it's something between both. It's the average between these two molecules, okay? So now that I will use just this one to assign the formal charge. Could use any one, it really doesn't matter, but we'll use that one in particular. So I have here oxygen, double O, okay? So for this guy here, 6 valence electrons minus 2 connections plus 4 electrons that is connected in a lone pair. 2 plus 4 gives me a 0. This guy here has 2 connections plus 1, 3. 6 valence electrons, 3 connections, and 2 electrons that is lone. So I have a plus 1. So this guy has a plus 1 formal charge. This guy here has 6 valence electrons minus 1 connection plus 6 electrons in a lone pair, giving me a minus 1. So this guy has a minus 1 charge. So if I write it, the formal charge associated with that particular structure, I have a 0 here, plus 1 here, minus 1 here. The overall, my molecule has 0 on charge, but this particular atom has a plus and this particular atom has a minus, and when we added everything, they cancel out, giving us a 0.